Hey, welcome back. Today's project has us at the mill, kind of obviously. For a while, I've been using these Tormach TTS tool holders, and they are absolutely fantastic. Being able to just throw a tool in, tighten up the drawbar, next tool, loosen the drawbar, take it out, next tool, and they are in the same spot every time. Repeatable tooling. Now the problem comes from the loosening and tightening drawbar part. Now these are supposed to be quick change tools, but this is kind of anything but quick. The stock way of doing this on the mini mill is this pin goes in, and then there's a detent in the spindle itself, and then you put something, tighten and loosen the drawbar here, pull that back out, and carry on. I mean, it works, and I mean, it's not that big of a deal, I guess, but it's cumbersome, and there's a better way. So my idea, actually, I'm cribbing my idea from a recent video that Stefan Gotteswinter put out, where he did an update on his mill about a month ago, and he posted pictures and a bit of video of making a spindle brake. And I thought about maybe doing a power drawbar for a long time, but I think that the spindle brake idea is better because, well, it's simpler, and also I'm sure there's going to be occasions where being able to lock the spindle for certain operations is going to be helpful. So what I'm going to do, these mills have a bearing cover, and I'm going to replace this bearing cover with a spindle lock. It'll pick up the 3 bolt holes like this, and then it'll have a section that sticks down with a slit in it so that you can tighten a bolt and it'll actually squeeze the spindle. So I'm going to go ahead and cut a big old piece out of this chunk, and I will see you at the lathe. Alright, we're set up at the lathe. Now these first 2 operations are the most critical. Establishing a flat face with a bore that is dead perpendicular to it, and pretty much a very close fit to this mill spindle. Those are the 2 most important parts of this. I think after that, outside of the bolt holes, everything else is just kind of as I want it. I mean, even the outside diameter of this is, I mean, it's a plastic piece that it's going in the place of, so just shy of 3 inches, 180 thousandths. So we'll do 3-inch 175 for the OD, but that'll be once we flip it over. So like I said, first we'll establish this face, drill and bore the center to fit the middle spindle, and then carry on from there. Okay, so I've got the part flipped around. I test fitted on the spindle of the mill. It's pretty much the fit I want. I'm actually kind of worried it might need to be a little looser, but I guess we'll cross that bridge when we get there. Now I'm just gonna face this off, bring it down to the same dimension as the bearing cap, and we'll go over to the mill and put some holes and some slits in it. So. Presto, one aluminum donut. All right, off to the mill. So over at the mill, I've got the part set up on a couple of pieces of sacrificial aluminum on top of a 1-2-3 block. I found center, and now I'm going to use the hole circle function to drill the 3 holes that will attach this to the mill. So measured this thing out. It's 80 millimeters in diameter, and the holes are 5 millimeters in from the edge. So the radius is 35 millimeters. We need 3 holes, and we'll leave the angles alone. Create circle, and we'll go to our first hole. Gear. And then plunge with our end mill. Alright, so I'm going to touch this end mill off down there, 0 my Z. I want this hole to end up 4 mil from there, 4 mil up. So we'll go back to our 0 for the hole. Okay. All right, that's holes. I'm gonna break this down real quick and test fit it. And then I'll set it back up and put the slit in it. Alright, so before I break this down, I forgot there was one more important feature to put in. And that is this cutout that makes clearance for the input shaft bearing. I'm not really sure what the radius is about 14.5 mil, but I just basically measured this distance, added half this diameter, because I know I'm centered, and it came out to 30.64 mil. I put a small witness mark and held it up against it. It seems to work out. It's just clearance for a bearing, so it's not super critical. I'm going to whittle away at this with an end mill and then come in with my boring head to make a nice semicircle. That was fun. I think that'll do. Now let's take it out and test fit it. Okay, next step is drilling the hole that's going to squeeze this thing together. There's a bit of eyeballing going on here. Like I said, I'm not making this from any plan. I'm just kind of making it up as I go along. The hole, the clamping hole, and the horizontal slit aren't going to be aligned, but I don't think that's going to matter. As long as the clearance part and the threaded part of the hole clear the slot, it doesn't matter. I used the 2 points from that bearing relief cutout and a 30-degree angle block, so I know that this hole, which has a gauge pin in it, is horizontal. And I'm going to pick up this gauge pin, and there's about 400 thousandths of space between the inner diameters of both of these holes. I'm going to put it right smack in the middle. So pick it up with the edge finder, and because I'm already 100 thousandths in because of the edge finder, I'll move over another 100, and I'll start drilling. Actually, I'll use an end mill first and then drill. Back into Imperial. Yeah, let's go down the middle. Okay, so I want this to go far enough past the slit that all the threads will be on the other side. Oops, sorry. I think right there will do. Okay, now just back to 0 and then drill to 0. All right, the last thing to do is tap. I'll bring you back when I've got it set up for the slitting operation, the last slitting operation. All right, hopefully this should be the last stop. Eyeballed the slitting saw along the line I scribed from earlier, and all that's left is to send it through. Hopefully it won't give me too much trouble. Oh, mother. All right. Hopefully that's the last stop. Take it out, clean it up, and we'll test it out. All right, moment of truth. Also off camera, I again taking cues from Stefan's build is the same kind of thing. I put an oil groove inside and installed a small ball oiler, because it's going to be in such, you know, basically in contact with the spindle all the time. So, but let's see if it works. Oh, let's make sure everything is nice and clean. And I'm just reusing the same 3 socket head cap screws that held the cover on originally. Get this snugged up. Loosen it a little. Make sure the spindle still rotates before we tighten everything down. And it does. Okay. Everybody's snugged up. Turn the mill on. No horrible noises. Although the real moment of truth. Let's see if we can lock a tool in without it spinning. Oh, fuck, yes we can. That's awesome. That is locked rock solid. And just a little, we're free to move again. That is fantastic. Oh, that's lovely. Guess we'll give it a bit of oil. Right in front of my head. Excellent. Well, I'm pretty pleased with how that came out, and I guess I owe a pretty big thanks to Stefan Gotteswinter for the idea. Now, obviously, I still have to use two different tools here, but I'll probably make some kind of lever to go here, or maybe a cam lock or something along those lines, something to make it just quick release. But that'll be for another day, because right now I'll just deal with this. Well, I hope you enjoyed that. Hope you took something away from it. I'll see you on the next project.